Hello viewers, let us start discussing about or continue the properties and their proof. Properties, theorems and their proof in Laplace transform part 2. Properties and theorems of Laplace transform. I just continue with my previous video lecture. The previous video lecture is also available in the same playlist. You can just go through that to get an idea. So let me start with another property called the frequency shifting property. What is frequency shifting? If the Laplace transform of a signal is known to us, then Laplace transform of the signal which is modulated by e power at x of t. What is the answer? The answer is pretty simple. Take x of s and replace s by minus or plus a. For example, when we are supposed to find out Laplace transform of e power at x of t, you have to take x of s, replace s by s minus a, or take Laplace transform of e power minus at into x of t, for which the Laplace transform need not be computed. Take the previous Laplace transform of x of t, which is x of s, replace x of s where s is replaced by s plus a. When there is a minus negative sign in the e power tau, here you will get s plus a. When there is a positive sign plus is available, here you will get s minus a. Let me prove this. How to prove it? Proof of this theorem. What is the name of the theorem? Frequency shifting theorem. By definition of Laplace transform, x of s is equal to Laplace transform of x of t, which is obtained according to the formula minus infinity to plus infinity x of t into e power minus st dt. Okay. What is the Laplace transform of e power minus at into x of t? Is very simple. In the place of x of t, now you have to use e power minus at into x of t. The remaining terms and all will continue as such. Can you identify? This is the portion for which we are supposed to calculate Laplace transform. Okay. So when the terms are combined, for example, integral minus infinity plus infinity x of t into e power minus of s plus a into t dt. The answer is so simple. What should you do? This is when compared with the formula x of t e power minus st dt is represented as x of s. Now in e power minus st, the place of e power minus s, you will get minus of s plus a into t. So this will be x of s plus a. Okay. That's why we say Laplace transform of e power minus at into x of t is given by x of s plus a. Okay. Let me go to the next property, which is called in the name of time shifting property. Time shifting property. If you know the Laplace transform of a signal x of t, right, it is given by x of s, then Laplace transform of x of t, for example, plus a, results in e power as into x of s. Very, very interesting to note. Similarly, Laplace transform of x of t minus a is given by e power minus as into x of s. Let's see the proof of it. Right? We have seen only the statement. Time shifting property of Laplace transform says that x of t plus a is equal to e power a s x of s. X Laplace transform of x of t minus a is equal to e power minus a s. So let's start with the proof by definition of Laplace transform. What is x of s? It is Laplace transform of a signal x of t, which is integral minus infinity to plus infinity x of t into e power minus st dt. Laplace transform of x of t plus a. Can you just view what is it? Integral minus infinity to plus infinity x of t plus a e power minus st dt. Laplace transform of x of t plus a, which is integral minus infinity plus infinity x of t into e power minus of s plus, sorry, what was the earlier term? E power t plus a, isn't it? If we start replacing, I'll introduce, if we start replacing t plus a by tau, then you would say t is equal to tau, right, minus a. Everybody knows about it. When you differentiate on both the sides, you'll get dt is equal to d tau, because a is a constant. Upon differentiation, this will happen. Okay, so because of that, Laplace transform of x of t plus a is equal to integral minus infinity to plus infinity x of t is replaced by t plus a, isn't it? In this place we had x of t plus a according to the signal given. So you can just now write it as x of tau e power minus s into t is replaced by tau minus a into d tau. Great, everything is fine. Now let me replace integral minus infinity to plus infinity x of tau into e power minus s tau into e power as multiplied by d tau. As far as the integration is concerned, all the terms having tau will be retained in it, so that only parameter e power as can be taken outside. Now we can say that the integral will be from minus infinity to plus infinity x of tau into e power minus s tau d tau. What is it? This integration stands for x of s. That's why we say Laplace transform of a signal advanced by an amount of a units will be given by e power as multiplied by x of s. Very good. This can be even modified into the other format also. Instead of advancement, if there is a change x of t minus a, if you have to find out the Laplace transform, you would say e power minus as into x of s. Agreed? So this is the essence of what is the property name? Time shifting property. Let me move on to the next property. What is the next property? The simplest property, which is called the name of differentiation property. Already we have seen one differentiation, isn't it? This time we are going to discuss about frequency differentiation property. If you know the Laplace transform of a signal which is equal to x of s, then if you are asked to find out Laplace transform of a signal which is multiplied by t, modulated by t, will be given by minus d by ds of x of s. Do you know how to prove this? Any clue? Proof. I will start explaining about the proof. By definition of Laplace transform, x of s is equal to Laplace transform of a signal x of t, which is equal to integral minus infinity to plus infinity x of t into e power minus st dt. That's it. But what is given here as a signal? T into x of t. So how should we replace it? How to obtain it? Instead of going in the forward direction, since we are much more concerned about the differentiation in frequency domain, why don't we take x of s and then differentiate it once? We will take this x of s, differentiate it once with respect to s. Let's see. Differentiate with respect to s on both the sides. So it will become d by ds of integral minus infinity plus infinity x of t into e power minus st dt. Did you notice one thing? The entire integration, there is only one term having s. So integration is not affected. Even x of t is not affected. So d by ds of e power minus st. What is it? Multiplied by dt. Multiplied by dt. So let me find out what is the signal. It is integral minus infinity plus infinity x of t into, right? If you differentiate with respect to s, minus t into e power minus st, because it is not, it is differentiated with respect to s dt, right? So let me conclude the expression now. This will become integral minus infinity plus infinity, all the t terms, so minus t into x of t. I arrange the term e power minus st dt, or I would say I'd recommend you to use minus integral in minus infinity to plus infinity t into x of t e power minus st dt. What is available on this side? It is the result of differentiation of x of s with respect to s. From this expression, the property is derived. What is the property? Very simple. If I take minus to this side, d by ds of x of s is equal to integral minus infinity plus infinity t into x of t e power minus st dt. What is the meaning of it? It's so simple. You can say that it is Laplace transform of t into x of t. So I'll write it 100 times. Laplace transform of t into x of t is equal to minus rate of change of x of s with respect to s. It is called frequency differentiation property. Okay, let us see the remaining properties also, like frequency scaling, time scaling, periodicity, convolution, initial value theorem, final value theorem, frequency integration, all those properties and their proofs. I'll give them one after the other. Thank you.